I'm just going to give a quick overview about our group. So we are not Azure community, we are serverless community, and we started like gluing this Lambda function in Amazon and kind of like kids playing with Lego boxes. And then over the time, that agility enabled us to build prototypes faster and give superpowers to front-end developers. So as the time started going, we realized that these are like three legs of the stool that overlap, like development, UX, and the product, that are leading to agility. And then, like, if you build products faster, somehow we became friends with the product managers, and we meshed really well with them. So you will see in the past meetups and the future you have, it's all geared toward building products faster with the least stress. So that's a kind of serverless became from functions as a service, serverless mindset. And every meetup I recommend a book or a place to go. So for me, favorite book last year was the book Ask Your Developer by Jeff Lawson. It's about product management, building this mindset. So we do have this mindset. We are in this group, but unfortunately, IT change has to come top down. So I ask you to tell your managers and the owners of the companies about his work. Why I like Jeff's book. Like, there are many good books on product management, but he's not an agile coach. He's not a product management coach. He ran Twilio. That's the main behind. So he's describing philosophy he used to run multi-million-dollar business. So that would be my spin about our group, and I hope to see you in the future, even if you are only Azure Cloud, or like we're trying to be cloud agnostic, like to use any technology that will get things moving and business happier. And then, so when we talk about serverless mindset, I found this definition of serverless mindset in the most unusual place, Government of Canada. You would not expect them to be agile and to think that fast. But like the acting CIO and CTO Government of Canada had recently interviewed with Deloitte, and he gave people new to technology advice that technology should never be in hand by itself, and that you should focus on helping the users and achieving their business goals. So, and he also urged people coming in IT to understand the big picture. So that's very similar. Like I was joking about IT guys. We are like car mechanics. We like to pimp the cars. But the goal of the car is not to be in the garage for us to play with it. The goal for the car is to be driven. So serverless mindset allows us to drive business around. And so that was just a switch from functions as a service to mindset, and I hope to see you here. And so regardless of the cloud, and even regardless if you are in the data center, because Ben Coy, he's from making this from iRobot, making Roombas. He's one of the leading thought leaders in the serverless space. He says that serverless is state of mind. Like it's not about what decisions you make, but how you make choices. And so. Even in the situations when you don't have a cloud, you can apply that thinking and towards serverless. Easy. That would be that. And then we were lucky that like a third year now, we have a Manning publication sponsor. They give a book title, or it doesn't have the book. It can be courses, videos, anything they have to a member. So we're going to have the raffle at the end. Also, Barry, I don't know if your offer is still valid. Like when we met, it was almost half a year ago. You offered like 30 vouchers, not 13, but 30 vouchers to the people in this group. So originally I thought 30 RSVPs, but I want to give it to everybody who came here. So we have 20 people now. Each of you will get, minus Barry, he gives those away. Get the voucher for 30 days of Pluralsight. And like Barry, you're going to tell them more about yourself after. There is so much you can learn from him and from other people over there. Upcoming serverless meetup, as I said, we are cloud agnostic. I was similar like this meetup, Lunch and Learn, enabled me to connect with a cloud study group in Germany and some Google group in Rochester, or is that, New York. And we organized, and also there is a Google Cloud community. So they asked us to create an event where customers share their stories. So next Thursday, this time, like Lunch and Learn, we're going to have two major presentations, practical presentations. One will be how to build data lakes, modern data warehouses using BigQuery, and another is going to be like like from zero to hero journey. We have a member, a kid in our group, Kuds. He started like playing with Firebase. Suddenly he has a business like 2 years later with tens of thousands of users. So he's going to describe how his pet project became a real business and what serverless Google services he's using. In a month after, there's going to be like Cloud Bill Shock experience. It's not Azure Cloud, but it's applicable to any cloud citizen. So you just want to come and hear a startup's own experience when he one morning woke up with 72,000 Cloud Bill. So I will keep it at that. So curious to see what cloud it was. And then John, I didn't even share this with you. I just kind of published this last night. This is going to be amazing. Like Joe Emison, he's like my serverless superhero. Like it's a ultimate serverless mindset. The guy does not care what technology stack he uses. He just wants to have businesses spawn faster. So within 3 years, I think he had 5 startups. And then he decided to go big. And the big is insurance company, which is running serverless. So in 2019, he had a talk how he built everything Amazon stack. It's a beautiful talk. But then at the end, he says, for reporting, we had to use Google BigQuery. So now he's going to explain the business analytics side of that same insurance company running on BigQuery. So this may be interesting for folks in Azure Cloud. I don't know anything about analytics powers, data lakes, warehouses that Azure have. Hopefully, Barry is going to open our eyes for that. But like in the case, like every vendor is going to tell you they have the best data warehouse. Like if you have a business, you want to go there fast, Barry's solution was linking Amazon and Google. So that's exciting. And then Barry, sorry, it took me 5 minutes. So here you go. I will stop sharing and you take it away.
All right, let me share my screen. Let's see how this works. It's always when I do a virtual meetup, then they move the cheese with every other application. This is now Google Meet, but essentially it's all the same stuff. So you should see my my slides right now. You see my slides?
Yeah, it looks good.
Okay, well, here we go then. Thank you very much, everybody, for taking time out of your lunch hour to be with us here. And thank you very much, guys, for having me here. It's an honor. It's always nice to be welcomed in a new group, and especially a group that doesn't do Azure. So that's really cool. Now, I'm Barry. I have a podcast called Developer Weekly Podcast. You can find that in all of your major podcast players and also at developerweeklypodcast.com. And that's about, kind of also technology agnostic developer stuff. So whatever the software industry has to deal with, as in design principles, being a software architect, working in the cloud, DevOps, you name it. I talk to people about that from Microsoft and from all over the industry. So also AWS, for instance, also Azure, also .NET, you name it. Check it out. There might be an episode in there that you might like. That's a weekly thing. You can also find me on Pluralsight. I have lots of courses about Azure, of course, but also other courses about continuous integration and continuous delivery, HTML, CSS. And I'm currently working on, and I'm so proud of this course, a course, and it will be done in a couple of weeks. It's called Identifying, Preventing, and Managing Burnout. So, burnout is very prevalent nowadays. Many people have it, and it's caused by prolonged chronic stress that is caused by physical and mental stress. In this course, I go into how to find out that you actually have a burnout, because that's not always that obvious, how you prevent one, and also how you recover from one with healthy habits and also changing your life. It's going to be a very interesting course. If you do not have Pluralsight, like Daniel said, we will then give away 30-day trial codes. Daniel has a bunch of them, and I gave them to him quite a while back. So it could be that these are about to expire. If they are expired, I will provide new ones for you guys, and that will be fine. So today we're going to talk about a topic that's also covered in the Pluralsight course, Microsoft Azure for Developers, What to Use When. And that covers lots of Azure services and what to use when to use one. Now, Azure has lots of services, AWS as well, Google Cloud as well, kind of all the same, Every cloud has kind of the same thing, the cloud, they all offer some Kubernetes service. They all offer some sort of relational database. They all offer some sort of NoSQL database. If one does it, the other ones do it as well, and they try to up each other, and then they try to out-innovate each other. So if you look at the overall services offering, there's really not that much difference in functionality. There are slight differences in performance, availability, pricing, all that type of stuff. But the functionality really is kind of similar there, which is good, right? And they all innovate together. Like this week was Microsoft Ignite. It's a big Microsoft conference where they always reveal lots of new Azure features and services. And they revealed lots of stuff in the AR and VR space, for instance, to make that easier for developers to create AR and VR applications, and also IoT. So they're focusing on that type of stuff, and also verticals, as in they're creating special cloud services for financial industry, special cloud services for the automobile industry, so that they can just get going quicker instead of building everything custom. And I saw that AWS, for instance, also are doing that. So they're all running after each other and they're kind of doing the same thing. But why am I then interested in Azure specifically? Well, Azure, for instance, has many, many data centers around the world. Like you see here, there are some that are generally available, some are being built as we speak. And all of these data centers together are more data centers than AWS and Google have together, which is nice. But that doesn't mean that AWS or Google are not as good as Azure, of course. Another thing that Azure also has is its own global network. So it has its own backbone of physical wires and also satellite connections that goes all over the world and connects all the data centers together. So that means that traffic from data center to data center is extremely fast, is secure, and also costs a lot less, which is very good. Now, this talk is because Microsoft Azure, like also AWS and Google, is extremely huge. You know, you have hundreds of services that do all sorts of stuff, and some seem to overlap in functionality. And, sometimes it is very difficult to gauge, well, what should I use when? Should I use Kubernetes now, or is a single container thing maybe better? Or should I maybe go for something completely different in this scenario? So, what should you do? Well, let's start at looking at a couple of categories here. I start with running your application in Azure and services for storing your data in Azure. And afterwards, we'll take a look at how to speed up your application in Azure. Let's start with running your application in Azure. Now, how I determine this, I do this by asking big picture questions. Like, for instance, how much control over the service do I need? Where do I need to run my app on? Is that in Azure or also on AWS or on an on-premises data center or on all of the above? And what usage model do I need? Is that a serverless thing? So something that runs only when I need it? Or is that something that runs 24/7 because, customers are from all around the world and it's a web shop or something? And once I've identified the answers to these big picture questions, I can take a look at the functionality and then match my requirements to whatever the functionality of the service is. And then obviously afterwards, I can also take a look at costs and SLAs, availability, performance, security, and such. For this talk, we'll keep it to functionality. Now, this framework is something that you can use yourself as well for AWS and Google. It's definitely not something that you only can use for Azure, because they are generic questions here. So let's start with the first one. How much control do I actually need over my servers? Well, that's all about the question between control and responsibility and working on business value. So if you want a lot of control and responsibility, then you have control over things like the network, antivirus, server configuration, operating system, application itself, and the application configuration, by which I mean the configuration as in configuring a database connection string, for instance, and application settings, stuff like that. Services that need a lot of control are services in the infrastructure as a service category. These are things like virtual machines that also AWS has, for instance, containers do the same thing. And when you have so much control, you might need that because you might need to install some custom things on there. Then you also have a lot of responsibility because that means that you also need to make sure that the operating system is updated. Now, Azure, for instance, has services that do that kind of for you, but you do need to make sure that that actually happens. And you need to make sure that the thing is secure, performant, and up and running, available. Now, when you move up the stack, so for instance, to platform as a service, you have less control. So you don't have control over the operating system or the antivirus or the network, but you don't need that. So you don't have the responsibility over it. You do have control over server configuration. So how much servers do you run? Scaling of the servers, 64-bit, 32-bit. Is it .NET or is it Java? Is it something else? And of course, the application and the app configuration. Now, moving further up the stack, we come to serverless. I call that logic as a service. You can say function as a service, whatever you want to call that. And here, the scaling is also done for you. So these services, they only run when you need them, and typically you only pay for them when they run as well. So in this case, you kind of only deploy your application. That's the thing you have control over, and you configure that thing. So with connection strings and app settings and things like that. Now, all the way up, there's software as a service. And there you don't even have control over the application, but also you're not responsible for the application. So you just use something. In Azure, that's something like Office 365, for instance, or Azure Cognitive Services, which are AI services that you can just use as REST APIs. You just call them, and Azure manages them for you. So when you are able to move all the way up the stack to working on business value, then you do not have as much control, but also not as much responsibility. So this is the first question that you need to ask yourself: how much control do I actually need for my application or service? Now, once you've answered that, you can move on to where do I need my application to run? Is that in Azure, so in the public cloud or in the government cloud or whatever type of cloud you have, or on Azure Stack, which is a hybrid thing in this case? Or is that somewhere else or somewhere else as well, like on premises, local development computer, or maybe also other clouds? Because lots of applications nowadays run on multiple clouds, like in Azure and in AWS, for instance. Now, when you've answered that, you can talk about what usage model do I need? So, how will my application be used? Is that all the time, like a web shop, for instance, that's being used all the time from all over the world, like Amazon.com, for instance? Then you need to be up and running 24/7. And you use the classic model, which is always on, like a virtual machine, for instance, that you can run all the time. But for a thing like that, you also pay per month. You pay such a certain amount per month. In Azure, you also have Azure App Services, which is something you use to run a website or an API with. And that's kind of the same model there. Now, if you only want to run your application or service occasionally, so only when you need it, like for instance, an API, you only need to run it when you call it, then you run it in a serverless way. So logic as a service. And then, like Amazon Lambda, you only run it when you need it. And typically, you also only pay per execution, but sometimes you also pay a little bit for storage costs and configuration things that are stored somewhere. Now, when you've answered all of these questions, you can take a look at the functionality. Let's go through an example of these questions and answers to these questions. Now, I trust Azure to scale for me. So that means I don't need a lot of control, and I can look at logic as a service services. And my application needs to run in Azure and on premises. So both. Okay. And my application only needs to run once every hour. So not all the time, but on a certain schedule. Okay. So once you have this, then you can actually start to filter between all the services. Now, which services am I talking about? These. These are all the options in Azure for running your application. So there are quite a lot. There's virtual machines, which are virtual machines like you know them that you run on your local PC and on premises as well, but then an Azure managed variant. There's Azure Container Instances that you use to run a single container in. And there's Azure Kubernetes Service that you use to run multiple containers in with a container orchestrator, which is a thing that actually binds all of the containers together, makes sure that one is up and the other is up, and deploys your application to it. There's also web apps for containers, which is also used to run a single container in, but comes with additional features like easy authentication, for instance. And then there's also Azure Batch. And Azure Batch is something that you can feed a job to, like for instance, the rendering of a very large movie file. And then it splits that job up, scales it out over multiple nodes. And these nodes can run on virtual machines or containers. And once the job is done, it scales it all back and then it is done and combines the result and gives that to you. It's a very nice thing. There's also Azure Service Fabric, and that is a foundational service of Azure because many other Azure services actually run internally on Azure Service Fabric. Like Azure SQL runs on Azure Service Fabric, Azure App Services web apps also run on Azure Service Fabric. What does it do? It is basically a service that you can feed an application to. You can run anything in there, any executable, and it will make sure that it is up and running. So it will instantiate multiple instances of that service. It will keep it available, performant, and secure. You can do that with custom applications, but you can also feed it containers, and it will do the same thing for you there. There's also Azure Cloud Services, which is a very old service, one of the first services in Azure, and you can use that to run web applications in and also background tasks in. You shouldn't use it anymore for new applications because Microsoft is not actively investing in that. But if you have something running in that, that's totally fine. There's also Azure App Services Web Apps, which is kind of the evolution of that. And you can use that to run a web application or an API in. There's also Azure App Services Mobile Apps, and you can use that to run the back end API for a mobile app in there. And why would you do that? Because that thing also comes with functionality like push notifications and offline synchronization. And then there are Azure Functions, which you might have heard of. And Azure Functions are the equivalent of AWS Lambda in that they are serverless, tiny serverless things that can run. They're pretty awesome, actually. You feed them a little bit of code of what you want to do. For instance, when an image comes into storage, I want to resize it and then put it somewhere else. An Azure function can do exactly that. And it has useful bindings that allow you to then take an image, for instance, from an Azure storage place or somewhere else, and then put it somewhere without you actually having to write all the plumbing code to connect to that storage and write all that stuff. Those bindings are just there for you to make it easy. And then there's Azure Logic Apps, and you use that to orchestrate a complete process. You use that to say, all right, when this happens, for instance, when a message is on a queue, then I want to follow these steps. I want to call API 1, I want to call this function, I want to put this thing in SQL, and then we're done. So these are all the services that you can use for running your application in Azure. Now, these ones here fall under the infrastructure as a service category. So those are things like virtual machines, container services, and also Azure Batch, which runs on top of virtual machines or containers. And also Azure Service Fabric, because it can also run containers, which are infrastructure as a service. Then there's also platform as a service services. Also, Service Fabric falls into the platform as a service because you can also feed it custom applications, so not containerized applications. And that means that it will take that and run it and take care of all the stuff for you. So you don't need to worry about operating system, antivirus, network, all that stuff. That makes it platform as a service. Also, cloud services and Azure App Services web apps and Azure App Services mobile apps are platform as a service services. Goodness, I can barely pronounce all this stuff. And then there are the serverless services, which is Azure Functions and also Azure Logic Apps. Now, on the left there is control and responsibility, infrastructure as a service, and on the right there is business value. So this is the first shifting that you do when you answer your questions. You can already figure out which ones you need to not pick. And then if you want to stay vendor agnostic, like we said, our application needs to run on Azure, but also on another cloud, run anywhere, then these services work for you. So a virtual machine, for instance, because you can have a virtual machine image that you can run basically anywhere. Also container services, because you can run a container anywhere. And also Service Fabric, because it can run containers. And also Azure Functions and Logic Apps, because they run on a special runtime, the Azure Functions runtime, and you can use that to run anywhere. You can install that on your local machine, run it anywhere, or in a container, run it anywhere. If you want to run occasionally, so serverless, Azure Batch is also a thing. It's not really a serverless service. It depends on your definition, really. But it does when it is done with its job of rendering a big movie file, for instance, it scales back and then it's done. So it kind of takes care of the scaling for you, which kind of makes it serverless. And then, of course, Azure Functions and Azure Logic Apps as well. Now, let's compare the functionality of these services, and we'll cut it up into multiple categories because basically it just doesn't fit on the slide. So we'll start by comparing container options and virtual machines, which are Azure VM, Container Instances, Kubernetes Service Web App for Containers Batch, and Azure Service Fabric. So if you want to lift and shift your application to the cloud without doing anything to it, without actually making it cloud native, then you can use a virtual machine because you usually run it in a virtual machine already on premises or somewhere else, and you can just bring that virtual machine to Azure and then at least it's in the cloud. If you want to build a simple application on a container without an orchestrator per se, without a container orchestrator, you would use also a VM or a container instances as well. And if you want a complex application with an orchestrator, so multiple containers, you would use Azure Kubernetes Service, but also Azure Service Fabric like we just discussed, it can also run containers and has its own container orchestrator. If you want to run orchestrated microservices, then you can do that in Azure Service Fabric. Technically, you could also do that on Kubernetes, uh, which people do. It's very complicated though, and it brings a lot of headaches. So always think twice before you run microservices if you really need that. If you want to run your application anywhere, then Service Fabric, you can technically use these all, of course, but Service Fabric is really good for that because you can install the Service Fabric SDK also anywhere. You can install it on your local machine, on AWS, on Google, on premises, wherever, and it will run. If you want to run a web application on Windows or Linux with app service features like deployment slots, easy authentication, and authorization, like I talked about, then Web App for Containers is perfect for you. And then finally, if you want to run repetitive jobs on massive scale, then Azure Batch is the service for you. All right. So where to run your background tasks? We have cloud services, Azure App Services, Web Job, Functions, Batch. If you want short running tasks, all of these can do short running tasks. Long running tasks, guess what? All of these can do that as well. Resource intensive tasks, well, that's really for Azure Batch. So for really, really big things that might take a very long time. If you run on something that you pay for all month, so the classic model, then that's cloud services and web jobs because web jobs run on Azure App Services. If you pay only for what and when you run, so a serverless model, then you use Azure Functions and also Azure Batch, like I just said. And if you need to deploy a complete application to run with a lot of plumbing around it for a specific application, then that's for cloud services and Azure Batch, because when you create an application for these, you need to do it in a very specific template that the service can use and then can ingest. Azure Web Jobs and Azure Functions, however, only need the basic code that you use to actually run whatever you need to run. And that's it. And that's very attractive, I think. So, where to run your applications? We have Azure Web Apps, mobile apps, cloud services, Service Fabric, Functions, and Logic apps. If you want to host a web application, you would use a web application, an Azure App Services web app, or a cloud service or Service Fabric, because it can basically run anything. If you want to host your own APIs, then you can also do that in Azure Web App because it's really meant for all services that are HTTP based. Also, cloud services can do that and Service Fabric because it can run anything. Oh, and also Azure Functions because, it's a function. It can run any type of code really, and it runs only when you need it. So it's kind of perfect for an API. If you want to host a backend for mobile applications that can do things like push notifications and offline synchronization, then Azure App Services mobile apps is for you. And if you want to automate one step of a process, so for instance, an image comes in and I want to resize it, then you would use an Azure function. And if you want to automate a complete process where you have other steps after that, then you choose Azure Logic Apps that can string multiple functions or other APIs together in a complete process. If you want to enjoy features like deployment slots and authentication and other nice, easy features, then you choose the Azure App Services like web apps and mobile apps and also Azure Functions, which technically is also an Azure App Services service and also cloud service. If you want to run microservices at scale, then Service Fabric is really meant for that. Microsoft really uh, pushed the marketing machine there to make Service Fabric the microservices thing that you need. But also you could use Azure Functions because they can run APIs, and technically you can then run microservices on there. Might be a bit more difficult because you don't have any discovery mechanism and all that, but still it will work. So that was running applications, and now we take a look at storing your data in Azure. So again, big picture questions. What will I use the data for? And what type of data am I going to store? So let's take a look at the first one, which is what will I use the data for? Is that for my application, for my usually forms over data application, where people are actively using the database and data in my database, then it is an OLTP or online transactional processing database type. Otherwise, it is for data analytics. So big data, data that sits there and you want reports out of that or use machine learning or AI on that, then you would use a data store that's meant for OLAP, so online and analytical processing. And then what type of data am I going to store? Is that relational data, so tables with rows and columns, or is that something else, unstructured data, which can be documents, key value pair, graph data, files, whatever. So again, an example, my application is an online reservation system, which is then an active application, OLTP application, and my app needs to store and retrieve document data, so a NoSQL thing. Here are all the options for storing data in Azure. And I promise you that AWS and Google have similar services. There is Azure SQL Database, which is SQL Server in the cloud, relational data. There's Azure Databases for MySQL, for PostgreSQL, and for MariaDB, which is kind of similar to Azure SQL Database, only then for these specific technologies. And are really meant for people that are migrating from these technologies to the cloud so that they can then use a managed version of that service in the cloud that can scale, that is highly available, that's performant, and has other more advanced features. Also, Azure Cosmos DB, that is the NoSQL thing from Microsoft, and you can use that with multiple APIs, which is very cool. So you store data in there, it doesn't matter how, and you can then use that with, for instance, the MongoDB API, with a SQL API, and Cassandra API, other APIs as well. It doesn't matter because the data is abstracted away there. There's also Azure Storage, which consists out of multiple other services. Azure File Storage for storing files, Azure Blob Storage for storing blobs of data, Azure Queue Storage for storing small messages in a queue, and Azure Table Storage for storing stuff in a table, but not really a relational table, because in this type of table, you can have columns, and the columns can be different for every row. And there's also disk storage, which is kind of file storage, but specifically meant for mounting in a VM. So it's fast in that way. There's also Azure Synapse Analytics and Azure Data Lake Store, which are the analytical data stores. So the top ones are online transactional processing. They are geared for that type of application. So they are fast for reading and writing constantly. And the bottom ones are online analytical processing data stores, so meant for big data analysis, AI, and machine learning. These, Azure SQL Database, MySQL, PostgreSQL, and MariaDB, are relational databases. And these are unstructured and document data. These are data analytics. Also there is relational and unstructured, but we'll see that in a minute. So let's compare these, and let's start by comparing data stores for OLTP, so the ones that you use for your active application, for your forms over data application. We have Azure SQL database for MySQL, database for PostgreSQL, MariaDB, Cosmos, and Azure Storage. And I've combined all of the Azure Storage services there together because there are so many and it doesn't fit on the slide, and they kind of do the same thing. So if you want to store relational data, then you would use all of these. If you want to store semi or non-relational data, so NoSQL data, you would use Cosmos DB and also Azure Storage. Like I said, it also has Azure Table Storage, but that is not really relational there. If you can use Microsoft tools to manage the data, there's, for instance, SQL Server Management Studio, which is the old school tool. There's also Azure Data Studio, the newer one. You do that with Azure SQL, Cosmos DB, and Azure Storage, which are really the Microsoft Azure services. And you use other tools for MySQL, PostgreSQL, and MariaDB, the tools from that ecosystem. If you want advanced querying capabilities, then you use Azure SQL Database, MySQL, PostgreSQL, MariaDB, and also Cosmos DB, but not Azure Storage, because you can only use kind of OData queries against it. So you can query it, but not really advanced. And if you want to use multiple APIs to access the data, like I just talked about, with the Cassandra API, with the MongoDB API, Table API, other APIs, then you would use Cosmos DB, Azure Cosmos DB. Now let's compare the data stores for OLAP, which is Azure Synapse Analytics, which previously was called Azure SQL Data Warehouse, and Azure Data Lake Store. Now, if you want to store relational data, you would use Azure Synapse Analytics because it needs tables with rows and columns. Azure Data Lake Store can do that as well because you can store data in any format in Azure Data Lake Store, including also non-relational, so document and relational. It doesn't really matter there. If you need to create a schema before you can actually start to work, then that's Azure Synapse Analytics. Because like I said, it is a relational thing, which means that you need to create a schema before you put all of your big data in there. You don't need that for Azure Data Lake Store. The data store that has basically no file or database size limits, except for your credit card, of course, is Azure Data Lake Store. You can store as much stuff in there as you want. Azure Synapse Analytics is getting there. You can store a lot in there, but it is not unlimited yet. And the big difference here is you use this one, Azure Synapse Analytics, when you know which questions you want the data to answer. So you have certain questions that you want the data to answer. You use Azure Synapse Analytics because you need to create the schema of tables with rows and columns up front. If you have no idea yet what kind of information the data contains, then you'd use Azure Data Lake Store. And you'd use then machine learning, for instance, to find patterns within the data and delve that information out of there because you don't need to create a schema there. So that was running your application and storing your data. Now I have one more category, which is how to choose Azure services to speed up your application. Now these are just 3 categories. In the course that I just showed you the title of what to use when in Azure, from Pluralsight, there are like 10, 12 categories or something, because there are so many services. So options for speeding your application up in Azure. There's Azure CDN, Content Delivery Network. There's Azure Cache for Redis, which is a Redis cache managed by Azure. There's Azure Traffic Manager, and there's Azure Front Door. Azure Traffic Manager is a load balancer based on DNS. So you put that in front of your applications, and the traffic hits Traffic Manager, and then Traffic Manager can determine where it needs to go globally, for instance, based on performance or otherwise. Azure Front Door kind of does the same because it's also a global load balancer that you put in front of your application, but it's not based on DNS, it's based on HTTP traffic. So these are the questions that I ask. Are my users globally distributed or are they only local to, let's say, one region or country? And does my application use data that is used a lot and doesn't change often? And then also, does my application use audio, video, or images or other static files? You see where I'm going here. Are my users globally distributed? Well, if that is not the case, then nothing. If that is the case, then I need to determine is my traffic between users and application HTTP based. If it is, then I'd use Azure Front Door and put that in front of my application so that it catches all of the traffic and it can then route it to my application instances based on, let's say, geographic performance, for instance, or rules that I put in there. If that's not the case, if it's not HTTP based, DNS based, or otherwise, then you choose Azure Traffic Manager. Now, with both of these, you can still use Azure CDN and Redis Cache to then further speed up your application. And does my application use data that is used a lot and doesn't change often? So, for instance, data that changes often is data in an order table like this one. Orders are created all the time. They are deleted. They are updated, hopefully for your business. So this changes a lot. And it is used a lot. But this type of data you might use in a form, a list of countries that is constantly brought up, that is also used a lot, but it changes a little. Sometimes a country is added, sometimes a country is deleted, but that might be once a year. So this type of data, a list of countries, is perfect to put into Azure Cache for Redis to speed it up, to speed the retrieval of that up. Now, why is that? Why is that faster than, for instance, putting it in Azure SQL database? Because it is an in-memory data and it uses key value. So you put this in here with a key And then you can just retrieve it with the key without actually having to create a whole query and executing the query plan, which is what a relational database would do. That takes time, and that time you don't have to spend now in Azure Cache for Redis because you just plug it out of memory. Now, this thing also comes with some advanced functionality like geo-replication, where you can replicate the contents of this cache to other geographical regions, and also data persistence. For instance, when you use this within Amazon.com, you can imagine that if you store your shopping cart information in there, then every minute or so there's millions and millions of dollars of information in there. So if it were to restart, you would lose all of that information. So you can then also persist that data with an advanced feature. All right. If your application uses static files, so audio, video, images, JavaScript files, CSS files, you name it, then you can use Azure CDN. And that works kind of like this. So if you have a website that has these type of files, basically any website does, and your user goes there and your user is geographically close, that's all fine. But if your user is further away, then that becomes a problem because of latency. It takes longer. Latency is something like this. You measure it in milliseconds, and you might say, well, that's not a lot, 19 milliseconds versus 173. Who cares? But latency adds up. So if you have a web page and you try to pull that up, you might need 10 requests to actually do that. Usually it's a lot more nowadays with images and CSS files, JavaScript files, HTML that you're trying to download over the wire to your browser. And then if it's only 10 requests, you already have 1.7 seconds of latency. And that's not counting the download time and rendering it on the screen. So this adds up and makes things slower. Now, what can you do? You can use something like Azure CDN or another CDN to do this. And then when you have your static files, you put them in CDN, and CDN puts them in a point of presence, which is kind of like a data center, but there are a lot more points of presence all over the world than there are data centers. So now when a user uses it, the data is always close to a user because the data gets replicated to all the points of presence all over the world. And an additional advantage is here that when the browser then gets those static files, it gets them from the point of presence, so from the CDN instead of from the website. So it doesn't query your website for it, it queries another service for it, which frees up CPU cycles and download speed from your website. So how does that work in Azure? You have Azure CDN, and you create an Azure CDN endpoint, and then you put your static files into Azure Storage, Azure Blob Storage, for instance. You can also put it in other services. And then Azure CDN takes that stuff, takes those static files, and starts to replicate them all over the world in these points of presence. And once that has happened, what you need to do in your website, you need to just point to the CDN instead of to wherever the file was before. Let's say in your file system, looks like website.azure/edge.net/whatever.jpg. And you can make this a custom URL, of course, as well. And it should be HTTPS. So that's kind of how simple that works to speed up that. All right. So let's compare the functionality of these. We've kind of seen it already. If you want to upload traffic from your application and let it be handled by another application, you would use Azure CDN, like we just saw, Redis Cache as well, and also Azure Front Door, because Azure Front Door also contains a CDN. And if you want to bring data closer to your users, geographically closer to your users, you would use CDN, Redis Cache, and also Front Door. And if you want to bring your application closer to your user, you'd use Traffic Manager and Front Door because they can both geographically route the most performant route to your user. So, for instance, if I have an application instance in Canada and my user is from Canada or from somewhere around there, then Traffic Manager would detect that and would know, all right, this is way faster than sending this user all the way to the application instance in the Netherlands. So I'll send him to the one in Canada, which is the fastest. And then if you want to provide fast in-memory access to data, you would use Azure Redis Cache or Cache for Redis, whatever it's called nowadays. All right, those were all the services. Now, with Azure and with other clouds as well, it's very difficult to stay up to date because things change so quickly and there are so many services. Now for Azure specifically, what I use is the Azure Architecture Center, and after this there is a slide with links to all of that. This thing contains example solution architectures, example design patterns for the cloud, stuff like that. It's very useful for when you are looking for a solution and you're not sure how to do it or you want to be inspired. There's also Azure Friday. That's a show with Scott Hanselman, which is a Microsoft guy. And that's a weekly thing where he interviews somebody from the Azure development team about some service or a feature. Sometimes I'm on there as well. And then there are several blogs that I follow. The links you'll see in a bit. And of course, there's also Pluralsight with lots of courses about Azure, but also lots of courses about Google Cloud and AWS. And nowadays, also lots of certification tracks on there where you can say, well, I want this type of certification. And then here are all the courses that will take you there, including practice exams and cloud labs where you can actually hands-on try it and practice what you've learned. So here's a list of all of those links. I've sent these slides already to Daniel and he can distribute them to you so that you can take a look at this later. One thing that I didn't mention was Azure Tips and Tricks, which is a website on GitHub. It's open source. I also create for that, and those are weekly blog posts and small videos about an Azure service or an Azure feature, a video of 3 minutes or something. So it's very easy to stay up to date with that. All right, so you can find me on Pluralsight. If you go there, if you already have a Pluralsight account and you go to my profile, you can follow me. And when you do that, you get a notification whenever I release a new service. I've been saying service for a million times. A new course, or I update a course. So, for instance, the course about burnout. So follow me on there. And you can always ask me for a free trial code if you don't have it. And please also take a look at my podcast, which I'm very proud of. And next week is about React on the podcast. And after that, it's about Dapper, which is also interesting. So that's my story. Now we can do a Q&A. If you have any questions, please speak up. You can really literally ask me anything and I'll see if I can answer it.
Thank you, Barry. This was awesome. Thank you. Oh my God, so much to soak in, especially for the new folks. So, guys, first reminder, so not only that you're getting Pluralsight coupon codes, Manning is also doing the draw. I pasted in the chat URL for the free draw. We're going to use Wheel of Names. I'm not collecting any personal data, so please do that while we're doing Q&A. We still have 30 minutes, I hope, before our Friday afternoon meetup. To open the floor, maybe I can start reading the questions. I was writing down frantically like the questions that would that would be interesting for me. So I don't know about on-prem SQL Server migration to Azure. Like, what are the equivalent services? Because I'm asking from the special. Okay, SQL Server has this Joule always-on cluster. And I noticed, like, when we move stuff to my Google Cloud is my experience, we use Cloud SQL. But if the configuration on-prem is always on, you can do that. You have to do infrastructure as a service. So I'm provisioning the literally virtual machine and setting up the manually always-on cluster. What is the equivalent? Is there something that makes it always on, but I don't have to manage AIS? How would you like it?
So, what's the purpose of always on? That's to keep it highly available, right? So then in Azure, yes, you can do the same thing. You have with Azure SQL Database, which is basically Azure SQL Server in the cloud, you have multiple tiers. You can run that serverless. You can run that as a platform as a service, like I just talked about. You can also run that as an infrastructure as a service, where it comes in a virtual machine. You can also run that as a managed instance, which is kind of run by Azure and kind of run by yourself, which is kind of in the middle there. What I would do in this case, I would just use it as a platform as a service, so the regular Azure SQL there, and then choose whatever the availability you need, because they have different pricing tiers and they come with different availabilities. And I know that the premium pricing tier, for instance, has a very high availability SLA.
Okay,
I
so
think
it's
it's
like
actually
a flag you switch, like the knob you tune. You pay more, you get availability. You don't have to configure anything. It's truly
let
serverless.
me just check it, because I think this thing by default has an extremely high SLA already.
Mhm.
La, la, la. Here is, for instance, Azure SQL database business critical or premium tiers.
Mhm.
You can have 99.995% if you want.
Okay.
So
Wow.
I'm sure that is probably enough for your application.
Okay.
If that is not, you should really talk to your business.
So I don't know about like AWS limitations, but there is a 30 gigabyte storage limitations on, I think, gigabyte or terabyte, but 30 is the number for Google Cloud SQL Server, like data size. So beyond that, you need to go like to other options. So is there such a, like, are there any limitations database size like SQL Server, or just service that's like serverless and grows in Azure?
There is a limitation, as in I'm just if you
Um,
see me looking, I'm just
yeah.
looking it up. But it is very big. Let me see.
John, are you aware of the limitations in Amazon? Like I know with Google
Yeah.
Cloud
There will
SQL
be
it's
some
10.
limitations to any SQL server engine, but you got to question your application design at some point too, because
Mhm.
if you're really over 30 terabyte, you maybe should be well, not only partitioning using the engine
Mhm.
can do partitioning, but you might want to be more logically partitioning at the
Mhm.
application
Yes.
design to say, what the
Mhm.
heck are you doing with 30 terabyte there? Maybe some of it should be in a NoSQL, maybe some of it should be in other storages that are tied together.
Yes, that's exactly how Google thinks. It's time to go to Spanner. Like
Yeah, that's what I would be looking at too. And maybe not for everything. There might be core aspects of that application that really want the relational ties together and ACID transactions, all that kind of stuff. And then maybe there's other aspects where, hey, there's a lot of data here, but it doesn't need to be in relational tables. In fact, it's really slowing us down.
So that's exactly my question to Microsoft/Azure thinking, like, because we struggle to map that in the other clouds. This is natively Azure for SQL Server product. Can you maybe run that slide again, or share what are the options there? Where's that knob or something, like, because that may be the easiest path then to migrate these workloads. But that was one question. We can stop here. I have more.
Yeah. No. So I think you're very right. If you have so much data, you should definitely think about why you would run that in a very active database. So these are obviously relatively expensive,
Mhm.
but you probably won't need all of that data all the time, right? If you have
Mhm.
30 terabytes. There's definitely options there, because Azure SQL also has elastic pools and other, they also has sharding options where you can shard all that data over multiple servers there if you need to, but you should really ask yourself why you would do that, because it will definitely not be more performant when you do. Migrating your SQL server to there is a service called Azure Migrate. You can use that in the Azure portal, and that is kind of a wizard really, and it shows you, it asks you what you want to migrate, you can also install a thing that then will take a look at what you're trying to do there,
Mhm.
and then it will tell you what to do for which scenario. So,
Mhm.
for instance, if you're trying to migrate something, a production thing that is currently running, that's obviously different steps than if you're trying to migrate something that's offline at the moment. But as you migrate, and that can migrate different types of data, also MySQL and
Mhm.
different stuff. You should definitely take a look
Nice.
at that.
Nice.
Yeah.
Can I go with one more database related? Like, people are building
Yeah.
data warehouses from databases. So SQL Server, like in MySQL, you take a change data capture. There is products you download, and you just stream it wherever you want to stream it. You like pub subs, like warehouses or Kafkas. So there are, because I'm not Azure guy, there are multiple options here. I pasted the link here. There is like CDC, and then there is some temporal tables, and then like, how do you decide? Let's say, like, and plus there is a streaming option versus batch option. So let's say it's a batch upload to data warehouse. I want snapshot of yesterday's SQL Server activities on whatever business unit into there. What would I use? The article points to 3 options. I have no clue which way to go, and I don't have time to play. Like, what is common? What is the pattern? Even if you don't know, maybe you can connect me with some of your guests that are building warehouses from.
Yeah, for data warehousing, usually the go-to service is Azure Data Factory. which is what you would use to move data around and to shape that basically. As in, you have data from here, you need to do a little bit of transformation before you put it somewhere else, or a query or a filter or something. So Azure Data Factory is kind of what that is. That used to be Azure SQL Services Integration Services. Remember when you would run that on premises? It kind of doesn't exist anymore. That's now Azure Data Factory.
So that means it has connected to SQL Server. Therefore, I can take anything I want, and I don't need to worry. That's beautiful. Thank you so much. That was amazing. I have one more from my work. So now I see why I invited Barry.
Well, there's a few in the chat there too, Daniel. Maybe you want to put some others up first, or go ahead if you've got one more. If you've got one more.
So it's related to the migration of to the cloud. So everybody, like in other clouds, Unix way of thinking was you first use 12-factor app, modernize it, refactor, and then go to the cloud. And I've seen similar pattern with Azure recommendations. Migrate to .NET 5 Core, or now just .NET 5, and then you are cloud ready kind of and secure. But what do you do with the old crap? Like we have Borland app, 20 years old. How do you modernize it, put it to the cloud? And to make it worse, it's not a web app, it's a desktop app. So now I have RDP, a Windows Virtual Desktop. Like, how do you handle that, the old stuff that needs to be modernized?
Well, there's just stuff that you cannot modernize anymore. I read a cool thing on Twitter where they called this vintage code instead of. So I like that, but some stuff it's just too expensive to change, and it's just not worth it because it's just running. And why would you change it? But you do want to run it in the cloud or your service in the cloud because you don't want to run your own data center anymore. Then you would use Azure virtual machines or virtual machines wherever, in AWS or something. It's not really cloud. Well, it is cloud. It runs in the cloud, but you're not really utilizing cloud features. But at least the thing is then managed by the cloud. So you're not taking care of a virtual machine that's running on something under your desk or something.
So did I understand correctly? Like I know in Amazon there are two services, Workspaces and Upstream, for handling these RDP apps and Windows virtual desktops. Maybe I didn't hear what is the equivalent in that world for RDP apps.
So what are you trying to do? What is an RDP app? What is the actual application?
It's a Windows app that you access through RDP. So you kind of RDP into it. And then when I spoke to Amazon friends, they say if you use Workspaces or Upstream, it's fully managed service where you deploy all the apps. So you don't have to manage it as infrastructure as a service.
Oh, okay. So you would use, let's say, a virtual machine somewhere that's running this application, and then users would RDP into it.
That's what they currently do, and apparently Amazon has Workspaces and Upstream services that allow that. Google doesn't have anything native, but they work with company Itopia, so Azure must have something that because it's made by Microsoft.
Yeah, it's like a crowbar fix of getting an old application that still you can't throw it away. You don't want to rebuild it. So what do? You put it up on a VM and let people remote to it. Yeah.
So. Okay. So let's go back.
You can do that, but you should also take a look at what's it called? Windows
Virtual Desktop.
Microsoft Remote Desktop. No, Microsoft Virtual.
Yes.
Microsoft Windows Virtual Desktop or something.
Yeah.
I don't know the name exactly, but you have a similar thing in Windows, which is just a feature in Windows, which doesn't do that. But
okay. Cool. So let's go back. You can open the chat. You see the button here, so you can even take over and read them. So, hello, Barry. Thank you so much. That's Omer from Turkey. Thank you so much for the presentation. Can we run Azure Synapse Analytics serverless mode for relational data? Oh, that's a good question. I would have asked the same.
Let's see. Oh, right. If that is serverless. Oh, that's a good question if that's serverless already. I know that they've been working on that, but I don't know if that is live at the moment. It could be that there's just been generally available because there was just Microsoft Ignite. A quick Google will tell me the answer. Appears. Because it's a pretty expensive service, Azure Synapse Analytics. I know you can pause it as well, the service. So when you're not using it, you just turn it off, basically. And let's see what it can do. No, it can't do that yet. No. Oh, here it is. Oh, it is there. Blah, 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 blah.
You can paste the link in the chat. I'll share it with everybody else after, if it's worthy.
It seems that it can do that as well. It looks like that. That's basically, you know, the trend of all of the services, really, where they always try to also offer a serverless tier. For instance, there's API management that you put in front of a bunch of APIs to manage them, to get their traffic and to transform them and stuff, which was also very old school and very pricey service. And now you can also run that serverless. Because basically what I think is nobody was using that because it was too expensive. And now they try to, you know, cater to a different public in a serverless way there.
Cool. And I see one more question. Mr. Torti says, hello, Barry. What would be the best option for MVC pod application with MySQL backend that were not too costly? 1 or 3 p.m.
So
yeah, that's definitely.
Yeah.
What was that? Sorry.
He's saying like an MVC, like a proof of concept application, like
the model view controller, or
yeah, you know, it's just a website, right?
Yeah.
So you can Azure App Services. That's definitely a very good option for that, because it also has a free tier, so you don't really need to do anything there. It has MySQL, and like you just saw, you have a Azure database for MySQL, which is a whole database thing. But you also have MySQL as a feature in App Services, and then that's a little in-memory MySQL thing. So it's not really for production. For instance, if you start to scale, that thing is in memory and it doesn't really work, of course. But for a proof of concept, that would definitely work, because that will then all run within the same Azure App Service within memory, and you can run that for free. So Azure App Services, web apps for this one.
Perfect. So do we have more questions? There was one above. Oh, he had to leave. Did I miss any question?
I can ask another one there, Barry. You mentioned microservice orchestration at some point in your talk, and you were saying how the relevant technologies there would be the containers and the service mesh fabric and whatnot. Is there an orchestration solution for serverless in Azure? I know in AWS they have what they call the step functions, which is basically just a way of tying together a bunch of serverless functions with the kind of if this then that logic, which determines which one fires next and what it does. Is there anything like that in Azure, or would you be writing that coordination yourself in either another serverless function or on some sort of a container?
No, you would do that. Like I said, logic apps, for instance, is something that can tie all these things together. Where it's really a visual designer where you can say, all right, I want this thing to go, and then this, and then this, and then this. But there's also Azure Event Hubs, and you can use that to make things, send things to each other. So for instance, when this happens with an Azure function, just send that to that Azure function as an input, for instance. And basically that Azure Event Hubs can take events from almost any service in Azure to any service in Azure, and also outside of Azure. So that's pretty clever. Yeah.
Is it related to cloud events? There is international spec with these Kubernetes user groups about sharing events. So you mentioned it can send data to other clouds. So.
Yeah, I don't really know what the message protocol is there, but it does. I don't really know.
Cloud events, I think I.O.
Yeah, it is standardized.
Yeah, there is a CFC and whatever they call it.
Yeah, that's the name.
Yeah, okay. They have a project for standardization of events as well. Yeah.
Cool. Okay. So guys, we'll have soon to leave in 15 minutes. Any more questions? As you are preparing questions, please do the survey. Manning will do Manning draw. I'm just throwing ideas. If you're Azure guys, the books I bought and I didn't read, but they all towards the data engineering side, because that's what businesses I think will be needing now. So
yeah.
Any questions, or we should go to draw? Why are you shy? Like, this is supposed to be networking part at the end. Say hi. I can cut it out if you mess up. So while you're getting Kari to speak,
Valentin raised a hand. I saw.
Go say something. Nobody's answering you.
Daniel and Barry. Sorry for. I just have a question. Like, what we do in programming is that something called design. So every problem we will be solving it through a particular design pattern, right? Like in Java or Python. So as in cloud, you can solve the same problem with a multiple approach, right? Whether the data migration from on-prem to cloud or cloud to cloud ETL, any solution, any analytics, putting data in a warehouse and running some analytic queries. So do we have any recommendation like design pattern, like strictly like go by rules? These kind of problems, we can use this kind of design pattern, whether it could be a private cloud, public cloud, or a multi-cloud environment. Do we have anything like design pattern in a way of cloud environment?
I pasted the answer, but Barry can talk to that. That's the reason I didn't go Azure. That was turner for me. So many patterns. So the answer is yes.
But yeah, like you said, these design patterns are just cloud patterns and software patterns themselves. They aren't Azure specific. You can use this also on premises. You should use this also on premises, and or in any other cloud. There is not really an answer, of course, of which design pattern to use when, because that's a very specific thing there. On Pluralsight, I have courses about cloud design patterns. There's a series of 3 patterns around the themes of performance, availability, security, a couple others that talk about this as well, and that provide examples of applications that you can use. In that link that Daniel just shared there are also sample applications for all of these patterns there as well. So within the cloud, yes, you can basically use all of these or combinations of these, right?
Yeah, got it. This is the first time I just got to know like these are all things are available in place. It's already in place. I just came to know. Thanks, Daniel. Thanks, Barry.
So I have opinions about patterns. Like it's like a rigid, like it's like spell check. Like do not let your imagination and creativity be constrained by the patterns. If you think logically, you arrive to them eventually. Why I adopted Amazon Cloud? It was do it yourself. There were no patterns. To me, these patterns here were the layer of not BS, but the layer of things you have to do before you're allowed to play with Azure. Just slows you down.
But you don't have to do it. And you don't have
the way of pattern we apply should not bring a mess into our solution. Correct? So,
but you refactor constantly. You will change it. You learn from your mistakes. So that's okay. I'll post you the story about like making 1,000 pots and then getting the beauty out of your experience, or spending 1,000 hours on making one beautiful pot. And there was a school experiment based on that topic. The group of the children that was just tasked to produce as many pots as possible gave better looking pots at the end than the group that was learning how to make most beautiful pattern approved pot.
Okay.
So that's my take on the creativity.
Too much of pattern will miss the current design, right? Like, is that what you mean, right?
John is laughing.
Too much of keeping in mind, like applying too much of pattern, going by rules always, will keep our focus drifted.
It's also excuse to make bureaucracy and like it constrain you. Like balance. There is 50 shades of gray. Truth is somewhere in between.
It's all about the balance for sure. There's a spectrum there. You want to understand and go into something with a good knowledge of what the appropriate patterns are and what, safety things to be doing. But you're right. Everything that's right.
Yeah.
That's great. Sorry, go ahead.
Yeah. Daniel, please do share the story, whatever you were saying earlier. Like that would help me. Yeah.
We have only 10 more minutes. I'll paste it as you're doing the draw.
Yeah.
So guys, any other questions before we go to the draw? I see only 13 people signed up, and there was like at times over 20 people here. So put your names in the form. I think I gave you the link to the form above in the chat. Do you have it?
I see another question here in the chat, and that is that each connection has cost. How efficient is it with 10 or 100 APIs or microservices collaborate together for a call response from front-end viewing of service mesh architecture? What I'm guessing you're saying or you're asking here is that is it still efficient to use a service mesh architecture or maybe a microservices architecture with Azure Service Fabric Mesh or another service if you have a lot of microservices, like 100 or whatever, or 10, or when is it actually efficient? That's extremely difficult to say, because it really depends on how you are also organized. For instance, there are organizations that use microservices, and then they have teams where each team is responsible for just one microservice, and then it's responsible for creating that whole microservice and publishing it, deploying it, making sure it keeps running and keeps talking to all the other services. So that's a relatively big effort for one microservice, let's say. But other companies do with one team 100 microservices, for instance. That could be. Myself, I'm not really a fan of microservices. It's really a hype thing. Everybody is using it because it's cool, and they're using it then in Kubernetes, for instance, or a service fabric or whatever, which is really difficult to do, especially in production, because each microservice, each thing that you run is a production service. So if you have 100 of them, every one of them needs to be updated, needs to be performant, available, secure, and has a pricing tag, like you say also. And that's very difficult. And when one is down, what are you going to do? Then the whole application, or a part of the application, is not running if you've designed it correctly. But it's very, very difficult. Also, designing something like that and keeping it all right in your head and knowing which thing is out there to actually use is a very difficult thing to do. Now, I know it's not sexy, but an alternative is the simple layered application where you have your front end and your middle layer and your back end, and maybe some things like services and APIs on the background. For most applications, that's absolutely fine. I think microservices, use them, you can definitely use them, only if you actually need to use them, because there is so much overhead and complexity involved in them, and you can definitely fail with them. I don't know if that answers your question. Let me know. Okay.
Maybe I can add something, like, I don't know, is it a Azure answer, but recently, so Google was taking some Google courses. They're talking that network you showed, that internal network that vendors have, Amazon has it, Azure has it, Google has it. In Google, it's petabyte speed network. It's crazy speed. So the issue of speed of microservices getting to one another, it's out of question. So they even changing design patterns from you copying your data for the speed or making it monolithic. There is no point. Like, it's really fast to do remote procedure calls. So that's from the speed, slowness side of the question. With everything else, I agree. And Sam Newman, the god of microservices, is now advocating opposite. He had a go-to conference last year. He's talking exactly like Barry. So
does he? Yeah. Oh, I didn't realize that.
I'll send you the link.
There you go.
I'll send you the link. So go ahead.
Go ahead.
I was just going to say, Daniel, that Valentin was saying his mic was blocked. I'm not sure if it was. I don't know. Maybe just type a question, or I don't think we've blocked anybody's mic. Maybe there's something else wrong.
I don't block anybody.
Yeah, I don't know what the.
Or log out, log in again while we're here. And I will see how many of you did the survey. So only 40 responses, folks. So let's see what you want to know. There are the 14 are tests. That doesn't count. Okay, so this is tested. This is me, who is here. So Control-C. And then we're going to go to wheels of names. And then paste. Is there anybody here? Barry, you should win as well. John, why are you so shy?
What's that? Oh, I never go on the wheel, no. Okay, put me in. Okay.
Anybody else who is in the call that name is not here? Omer, are you here? Omer, I don't see you.
So this is for Manning, and then what, are you also going to do the other credits a different way, or how are you doing that?
The other credits you have to email me, because I do not collect any.
Okay.
So I'm hoping, like, I will let you know. So follow the meetup announcement. I'm hoping that meetup, Google Meet, is going to give me email addresses where you logged in. If it doesn't, then I will have to wait for you to ask for your prize. because I don't want to go it. I don't want to go to RSVP. People didn't show up. We shouldn't give them. We should give it to everybody who was here. If there is anything extra, we can share to outsiders. So what do you think about that?
Yeah, that's fine.
So any other name? We have 4 more minutes. Let's spin it.
But no, but sorry, you were talking about for the Manning thing. But what about the what was the other training thing called, Barry? Sorry, you said it 3 times, like plural or play.
The Pluralsight,
Yeah,
free trial things.
Yeah. Okay.
Omer, are you with us? I don't have your email. If you are gone, I don't know how to chase you. Okay, let's see in the chat. Did he post?
Yes, he's there. He's there. Yep. So he can.
I need your email address because I didn't collect it. You will choose. You will go to and choose anything from them. So it's just throwing ideas. I was looking at what Manning has. It doesn't have to be like a book. It can be course, anything. It's a really awesome place to learn. And I think I learned most of the stuff that I know from them and practically. So that's basically it. So is there anything else? We have 3 more minutes. I see Karen is joining us. Thank you, Karen, for arriving at the end. He is my partner in crime for the meetup next week. Like I said, I'm not going to do it, but then he convinced me to help him, and we're going to have this a big query and Firebase meetup. Karen, you want to say hi to the crowd? Karen he has the biggest cloud study network in Europe. I think like maybe 10,000. How many people have Karen? Oh, he's shy. Anyways, the cloud study network is a good place, and you can now borrow Stillberry from us. Anything else before we go? Very much appreciate so much you showing up and teaching us and taking all.
Thanks for having me.
So look forward to learning more from you, and definitely I'll visit your podcasts. So anybody else before we go? 2 minutes.
Okay, the blocking was from the browser, technically, when you joined the meeting. So it's
Oh yeah, that can happen.
And the question about the functions is called durable function. I post the answer. So whatever Amazon has, Microsoft has the same. The only problem is Microsoft always is copying Amazon on the function part. So, and they don't want to go. But the other question for the Synapse, can I use Synapse, whatever database is relational database? The answer is no. Microsoft just rebrand the Hadoop database as Synapse. So it's Hadoop. Whatever we can do with Hadoop, that is the answer.
Wow.
And that is. The other thing, what I will go, there is a so-called cache in AWS. They have this cache in front of DynamoDB, for example. Microsoft did amazing job, amazing job, because I'm very mad at them, but they call it DynamoDB. So basically, you have no Dynamo Cosmos. You have like DynamoDB in AWS, and you put your cache in the front. And you connecting NoSQL, and you have the cache. And then you have sort of SQL, relational database, and you put Cosmos DB in the front. Then you have Neptune in Amazon, but you have this Neptune is GraphDB. And you have Cosmos DB, same API, GraphDB. So with Cosmos DB, Microsoft 2-3 years ago, they introduced relational database, SQL sort of relational database, which is serverless. So basically, there is a time delay and there is a problem, let's say, where I'm not happy. You can have only 500 requests per second. So, but the serverless SQL is a very good case where you can lower the price and you can have serverless when you have not much calls. And the time, let's say, one request is costing my 2 times it. Now I make test cases. The one was a month ago is around 300 milliseconds. If your service is okay with 300 milliseconds, and they now working always to have one thread up, so to lower the, but with Cosmos DB, technically they matching whatever DynamoDB, 8 milliseconds, 10 milliseconds request. So whatever Microsoft has, and Amazon, they have it. So, and Microsoft, technically, I'm a Microsoft guy, but I'm using the three of the clouds. Anyway, which one is cheaper? But they have. So the functions, Microsoft don't develop too much. They have so-called premium functions, where they want you to come with front money. And for example, they don't expend more than 1.5 gigabytes for RAM. But Microsoft are cheaper than Amazon. Whatever Amazon is giving, Microsoft is coming after that and offering a cheaper service, but always.
Very, very insightful, but you need a better microphone. So I'll go through the recording again to follow everything. There's lots of information, important info, but I missed it. Barry, were you able to catch everything?
Not everything, no.
My mic is on the camera, so I have old computer. I'm old guy.
Me too. Me too. Yeah. But my wife made me do this.
my computer is 7-8 years old because desktop. Because I'm buying, let's say, from Dell refurbished all the time workstations, and I'm looking Xeon processors, video cards a lot, and I don't care about the rest and the memory a lot.
Valentin, where are you from? Is it you?
Yeah, we met a couple of times. I'm Bulgarian origin, but in Haifa.
Cool. So I would like for you to be guest at one of our upcoming meetups to share experience. But we have to have better microphone. Okay.
Yeah.
So we'll talk about that after offline. Anything else? We are past time. Like I don't have any meetings right now at work, but most of you had to leave already. So, or we're just gonna say goodbye. I wish Barry all the best, success with career, with podcast.
Barry, I have a question. Barry, for a long time, I'm not in the market to study because my manager, he said that is personal initiatives to have classes and certificates. But last year I was studying around 6 months. I passed 4 certificates, but which one? I missed the first part because I was on the meeting in my work. Can you just say what we're doing on the Pluralsight? I love Pluralsight, by the way. For many years, I had systems.
Barry, question is, what are your courses on Pluralsight that you recommend to him?
Oh, okay. Well, I have lots of courses. I would start with the What to Use When course, which is basically what this talk was based on. And there you get a big overview of all the services within Azure and what they do, basically. And from there, you can definitely go deeper into the different services, because for each service or each service class, there's courses on Pluralsight. And then you can also do certification paths if you want. There's also AWS and Google stuff on there as well. So it's not only Azure. And those just guide you through a whole certification if you're into that type of stuff. So yeah, I would start with the Azure What to Use When course.
I passed this part because I was part of the Microsoft private preview, which meaning when Microsoft, before they was in the beta version, they invite me to test Azure, and I was giving feedback. And it's very easy with Microsoft. You suck, and done. Cool. Yeah, I passed this basic things a long time ago. If there is advanced courses, I love Pluralsight.
Cool. So let's stay in touch. So we need to wrap this up. Any other final thoughts, John? You wanna?
No, I was just saying, yeah, we got to wrap up and get going. But no, that was excellent talk. Thank you again, Barry.
All right, thanks for having me.
Have a good weekend and stay safe in these weird times.
Yeah, you guys too.